Well, let's get started looking at the bones of the vertebral column. The vertebral column is made up of individual bones. This image here shows us just a general view with various parts labeled. A little difficult to decipher without taking it apart. So let's take the vertebra, these 24 individual vertebra that are found in the vertebral column, and let's look at some of their parts. The parts are going to fall into four major categories. First is the simplest. The weight-bearing part, the largest part of the body, is the body of the vertebra, is the body of the vertebra. And these stack together with the intervertebral discs, as we've seen looking at the entire vertebral column. These are cancellous, bone inside, and compact on the outside. The second part to look at is the part immediately behind the body, which is known as the vertebral arch. And that extends in a posterior direction from the body in a curved fashion. The spinal cord lays right behind the body in a vertebral foramen that is created by the arch. The arch is constructed from four segments of bone. The first two segments are called pedicles, and you can see that they connect directly to the body and form the first parts of the arch. The remainder of the arch is formed by two lamina, and these lamina unite together to form the spinous process. So that the arch, as you see it here, are the two reds and the two blues. You can see that the arch completely surrounds and protects the spinal cord. When you stack all the bodies together into a vertebral column, you then have a tube-like cavity running down through that area there. And if we just take that out of there, you can see that this hollow space right here is called the vertebral foramen, and that is where the spinal cord is, and that is created by the arch. There are three processes then. If you take the third segment, then the third segment of objects are the three processes that extend from the vertebral arch. We just said that the two lamina together fuse to form what is known as the spinous process, which we'll outline right here. And notice it's right at the juncture of the two lamina. And then at the juncture of the pedicles and the lamina, there extends two transverse processes, and we'll outline those here. So, first the body, then you see the vertebral arch. Now connected to the juncture of the four parts of the vertebral arch are the three processes. The spinous process sticks completely posterior, while the body is anterior on the vertebra. And the vertebral arch is found in each type of vertebra. Let's put it into our thoracic vertebra, the two pedicles. And you can see this same little part here in the cervical vertebra here, and over here in the lumbar vertebra. And then, of course, the lamina, this thoracic vertebra in the center, and over here in the cervical vertebra, there are the two lamina, and over here are the two lamina in the lumbar vertebra. So every vertebra has a vertebral arch constructed of pedicles and lamina, and this protects the spinal cord or spinal nerves in each case. Spinous processes are here. Notice that they're somewhat different, especially that two-pronged or bifurcated spinous process in the cervical vertebra. And of course, each one has transverse processes. You can see that they're very large in the thoracic vertebra, and that's to help stabilize each rib. They're a little bit reduced in the lumbar vertebra, and they're very, very small in the cervical vertebra. but in each case they're there. The fourth element of each vertebra are what are known as the articular facets, and they join one vertebra to another posterior. The bodies unite the vertebra anteriorly, and these facets unite the vertebra posteriorly. Look at the picture on your right, and you'll see immediately behind the intervertebral foramina, those holes that you see, there are processes that reach down from a vertebra and reach up from the neighboring vertebra. And the union of those two creates these intervertebral joints that you see there. And I've outlined them here for you, especially the lower one there. You can see how a piece from below and a piece from above are coming together in that one spot. The articular processes meet posterior to the intervertebral foramen, as you see there. Now let's look at them in more detail over here on the two vertebrae. These again are thoracic vertebrae, but they could be any of them because every vertebra needs to join its neighbor. In the picture here, we've now highlighted and colored what are known as the articular processes, pieces of bone that stick up from the vertebra, and in this case superior articular processes. And you can see how they stick up from the other parts of the vertebra to reach up and meet the vertebra above. These processes have facets on them, the facet being the flat articular cartilage surface where it will actually meet or touch or join the other vertebra, the one above it or below it. Each vertebra has a process that sticks up and a process that sticks down, and that's the one that you see here. Maybe you can look back at the picture on the right and see how the process that sticks up from each vertebra meets and touches the one that sticks down. If you look at the real vertebra column, as they've put it here in the picture, again you can see those structures. Here are the superior articular processes, just two, but of course every vertebra has one. And here of course are the inferior articular processes, again just two, but everyone has one. And perhaps this is where it's easiest to see how the superior process of the inferior vertebra is in contact with the inferior process of the superior vertebra, and how this contact is immediately behind the intervertebral foramen. And there, right there, highlighted is the joint itself. That is a synovial joint. So, given a vertebra all by itself without the others to meet it, there is a superior and an inferior articular process. And there's the superior process, and there of course is the inferior process. Each process does have a flat facet structure, a cartilaginous surface that allows it to create a synovial joint. And notice that the way we describe this, the facets here, is that they face anteriorly and posteriorly. This is going to differ in other vertebrae. For example, here in the lumbar vertebra, we have the exact same articulations. You can see them here. And yet the surfaces that touch and meet one another are not the same. Given a single vertebra, here's the superior articular process on this lumbar vertebra, and here's the inferior articular facet facing us on the process that's sticking down. So again, a superior articular process sticks up and the inferior one sticks down, and they do that to meet the vertebra above and below them. And as you see in the picture, they are again immediately behind the intervertebral foramen. Looking at the top picture here, you can see these facets right here, and notice that these do face differently. Instead of facing anterior and posterior like in the thoracic vertebra, these facets face in a medial and lateral direction. The superior facets are facing medial, and you can see these inferior facets are facing lateral to meet those lumbar vertebra facets, the superior facets. So again, each vertebra locks into one another, just like they would in a thoracic vertebra. So the articular facets join one vertebra to another. The facets here face anteriorly and posteriorly in the thoracic vertebra, and that does make them as one very, very distinct structure that you can look for that will tell you whether you're looking at a thoracic vertebra or a lumbar vertebra. In fact, that's the question now. How do you tell one type from another? And you will need to do this. When we get to the practical exam and you're handling the real bones, there will come a point in the test where a vertebra will be laying on the table. You will need to pick it up, examine it, and tell me whether it's a cervical, thoracic, or lumbar vertebra. So, in 2 steps, you can tell the characteristic of any vertebra that you see. First question, are there transverse foramina present on the vertebra? Now, the transverse foramen are the little holes next to the transverse process. You can see on this cervical vertebra here. We showed you the little tiny transverse processes there. And you can see that there are special little holes formed next to the pedicles, right next to the transverse process, and they're called transverse foramina. So you ask yourself this question first, are there? And this is where you go from there. If the answer is yes, then it is absolutely a cervical vertebra. Every one of the 7 cervical vertebrae have these foramina, and no other vertebra does. So if you see that hole, then it's a cervical vertebra. If you don't see that hole, then it's thoracic or lumbar. So how do you tell these two apart? Here's a thoracic and here's a lumbar. And of course I'm going to take you right back to the shape of the articular processes and the facets. Which way are they facing? What do they look like? Right? If they're anterior posterior facing, it's thoracic. If they're medial and lateral facing, then it's lumbar. So, in 2 questions here, you can pick up any individual vertebra and know whether it's cervical, thoracic, or lumbar. Okay. Other than that, there are some special characteristics that we need to examine of the cervical of 2 of the cervical vertebrae. All of the thoracic and all the lumbar are alike, and most of the cervical are. But there are 2 special ones. And as we said just briefly, all cervical vertebrae have transverse foramina, and the other vertebrae do not. The 2 vertebrae that are special in the cervical area are the C2 vertebra, which is named the axis. You can see it here in the upper picture from a superior view. You can see it in the lower picture from a lateral view. The C2 vertebra has all of the features that every other vertebra has. It has a body. It has pedicles. It has lamina. It has transverse process, spinous process. It has superior and inferior articular facets. You can see those laying right beside the body there. It's much more compact than some of the others. It's got the transverse foramina. And it has one thing that no other vertebra has. So it is like every other vertebra with all of its parts, but it does have one feature that makes it unique. And this is called the dens. And you see it sticking up from the main body of the vertebra. You don't see that body portion like you see on so many other vertebrae, because right above the body is this dens. And the purpose of the dens is that it extends up in a superior direction and fits right up inside the C1 vertebra, called the atlas. If you were to look at the axis, or the atlas, which is a sort of ring-shaped bone, the dens would fit right here in the anterior position on that atlas vertebra. So there is a unique axis, which is like every other vertebra, has all of the regular parts of a vertebra, but it has this dens that reaches up and sort of stabilizes the C1 vertebra called the atlas. And the atlas is the one vertebra that is least like any other. I've drawn the dens in here from the axis, and you can see how the atlas fits around it. It's much more of a ring of bone than any others. The atlas has some features that are like other vertebrae, but not all. It has a transverse process. Those stick out. It has the transverse foramina, like all cervical vertebra. You can see it's right in the midst of the transverse process. This atlas has superior and inferior articular facets, where it meets the C2 vertebra and where it fits up against the skull, this being the first vertebra in the stack. It has a vertebral foramen. Spinal cord runs right down through this major opening here. What it doesn't have is a spinous process. It doesn't have a body. It doesn't have lamina or pedicles. The features that create the ring here are unique to this atlas, and they include the anterior arch, which is the one that fits right up against the dens. You can see it's the shorter one of the two. That's how you know the anterior from the posterior on the atlas. And then there's a posterior arch of bone here that makes room for and protects the spinal cord. So you want to make sure that you know the atlas, and you want to make sure that you know the axis as very unique members of the cervical vertebra. Finally, when we come to the bottom of the vertebral column, we come to the sacrum. The sacrum in the womb grew as 5 separate vertebrae. These vertebrae, though, fused together in the womb to create a single piece. Many of the basic features that you see in a vertebra are here. This is the anterior view of the sacrum, and what shows you that there were 5 vertebrae there are these transverse lines. Transverse lines still show the separation between the 5 fused vertebrae. So in the image here we see the sacrum, and we also see the last part of the vertebral column called the coccyx. You can see here it's 4 little vertebrae that become fused. And these are little teeny weeny vertebrae, and they form what is commonly known as the tailbone or the coccyx. On the posterior side of the sacrum, we see elements of all of the vertebrae in a fused form here. So what do we see? These fused vertebrae still form a canal. When we have separate vertebra, all the vertebrae stacked one above each other, all of their vertebral foramen line up and create what we call a vertebral canal. When it reaches here and the vertebrae are fused together, there is a sacral canal, and we usually indicate it at the superior end here. The inferior opening of the sacral canal is known as the sacral hiatus. You see that here. What would be the spinous processes of the vertebra are still here. They still stick out, but this is known as the median sacral crest. And it's a series of little lumps, which of course were once spinous processes. There are also holes that you see here that would be like the intervertebral foramina. This is known as a dorsal foramina. And let's explain that just a little bit more, because the foramina that are on the opposite side are called pelvic foramina. And the dorsal and pelvic foramina seem to be the same whole because they're lined up, but they are actually separate openings from the sacral canal. Pardon me. The pelvic foramina are here, and this being the anterior part, you can see where this comes from. This anterior part of the sacrum faces right here into the pelvic cavity, and so we call them the pelvic foramina. You can see how these pelvic foramina are separate from the dorsal ones by looking at a cross-section of the sacrum. Imagine that we cut transversely or across the main structure of the sacrum. This shows how the nerves exit through the two separate openings here. And just to get your bearings, this is the anterior and this is the posterior of the sacrum that we've cut through. This, of course, is that median sacral crest running down the back. Here's the sacral canal, where you can see the spinal nerves are located. And so the pelvic, since this is the anterior side, the pelvic foramina are located here, and the dorsal foramen is located here. So even though they're lined up and you can see straight through them, they really are separate openings from the sacral canal, from a uniform individual inside space. And so we do have separate nerve structures exiting each one of those openings. So you do want to be able to tell the dorsal foramina from the pelvic foramina, and part of that is knowing the anterior side from the posterior side of the sacrum. And so here again are the dorsal foramina on that posterior side. So let's summarize our discussion now of the vertebrae themselves. You want to, in your mind as you study, make sure that you know the four groups of regular structures. You should be able to pick out the body on any vertebra. You should be able to pick out the vertebral arch, the part that protects the spinal cord, made up of pedicles and lamina. You ought to be able to pick out the three major processes, the spinous process and the two transverse processes on any vertebra, whether they're large or small. And then you should be able to pick out the articular processes, superior and inferior, that join a vertebra behind the intervertebral foramen to its neighboring vertebra above it or below it. These articular processes do what they say. They create a joint, an articulation, a synovial articulation in the posterior part of the vertebra. Also remember the unique cervical structures. Should always be able to pick out a transverse foramen, which is unique to cervical vertebra only. Should be able to pick out the atlas with its arches and the axis with its dens. And you should know the structures of the sacrum and the coccyx. If you can do these things, you can pick up any vertebral bone, and you can easily tell where all of its parts are. So hope this helps, and study away.